Now to a story that may make you feel a little uneasy. Last night, a giant asteroid passed by our planet. And depending on your perspective, it either was no big deal or it was closer than you'd like it to be. So let's learn a little bit more about this from Time Magazine senior science editor Jeffrey Kluger. Thanks for joining us this morning.
Thank you.
This is kind of scary, I think.
Scary.
But I'm not sure. So tell us a little bit about this asteroid that passed close to us.
Well, this asteroid came in at 3.6 million miles, which is 15 times the distance to the moon. So that feels like a nice, clean cosmic miss. On the other hand, on the scale of the entire cosmos, it's very close. The way I like to think of it is, if the Earth were a person walking down the street, this one came by at treetop level. But the one that came by in February at 17,000 miles in altitude, that one would have parted our hair.
So, but Jeffrey, I mean, you mentioned the other asteroid, which of course we all are well aware of the impact that it had.
Right.
That was a surprise. We've known about this asteroid for 15 years.
That's right, and that's the trick here. The one that came in that buzzed Russia back in February actually came in with the sun behind it, so it had the same advantage fighter pilots have when they're flying out of the sun. You can't see them coming. The thing that makes it tricky to track asteroids is that we know there are 1 million near-Earth objects out there, and we've only spotted 10,000 of them so far, so there are a lot of them still out there flying blind.
So this asteroid, we didn't even mention the name. It's the QE2, or the 1998 QE2, 1998, because that's when it was first discovered.
Right.
It's huge.
It's huge.
Right? 1.7 miles.
That's 1.7 miles across. Now, again, the one that just missed us in February was only 150 miles across. But these things travel so fast and pack so much energy that if that one had hit, it would have released enough energy to be the equivalent of 180 Hiroshimas. This one, if it hit yesterday, would have been 11,000 Hiroshimas.
Which would have destroyed us, wouldn't it?
Well, it would have caused serious regional damage, but it also would have set up a cloud of haze throughout the atmosphere that would have affected the entire planet, and that's essentially what killed the dinosaurs, although that rock was even bigger.
This asteroid actually is going to come around again, isn't it?
That's right. The thing about asteroids is they orbit. Just like we orbit the sun, asteroids orbit the sun. We have gotten incredibly good at tracking the trajectory of these things. So when we know their mass, their trajectory, and their speed, we can track them out to 200 years or even further if we want to. This one's coming back. It'll be here in 200 years, but it's going to miss us again.
So, I mean, I guess it's fine and dandy to be able to track this, but I don't know if we're if it's more information than we need, knowing when something like this is coming. I mean, could we do anything about it if it came closer, if it changed its trajectory?
Yes, we can. Actually, we've gotten very good at dancing with asteroids. We can orbit them, we can land on them. We're sending a mission out in 2016 that will
there's a show in that, a reality
Dancing
show.
with Asteroids.
Yes.
I think it's a Kevin Costner movie. And it will land on it and bring back a sample. What we don't want to pretend to try to do is blow these things up, because then all you do is create a cluster bomb. Instead of one big asteroid, you get 20 smaller ones. We can't track them. What you do, though, is land on them, attach a rocket engine, and tweak their trajectory slightly. By the time they reach us, they miss us cleanly.
That's very cool.
Yeah.
Is there anything bigger out there that we should be concerned about?
Oh, yeah, there's lots bigger out there. The biggest asteroids out there, they're safely tucked in the asteroid belt, are Ceres and Vesta. One is the size of New Mexico, one is the size of Texas, but they'll never get near us.
That's good news. Thank you very much, Anthony Kluger.
Jeffrey Kluger. Thanks, Jeffrey.
Jeff.
And we've gotten very good at dancing with asteroids. I love that.
We have.